Hello everyone, this is the video continuation for the chemical reactions of amines. Now in the previous videos we have discussed the basicity of amines, where we compared the basicity of alkyl amines with that of ammonia, and then aryl amines and also ammonia, and also we have seen the comparison of the order of the strength of the basicity of the primary, secondary and tertiary amines. Now, in this video, we will be discussing the different chemical reactions of amines. The chemical reactions of amines are alkylation reaction, acylation reaction, carboamine reaction, electrophilic reaction, and many other more reactions. Therefore, first of all, let us first discuss the first chemical reactions, that is alkylation reactions. Amines undergo alkylation reaction. Therefore, the reaction can be represented as amines. The amines react with alkyl halides. Now, in alkyl halides, we know that the halogens are a good leaving group. Now, the lone pairs. Now, we know that amines are good base. They are a good base. Therefore, the lone pairs they donate easily. The lone pairs are donated to the alkyl group, and the bonding along the halogen atom along with the two bonding electron leaves. Now, we see here that we will find here we'll assume that this is our R dash. So since this R dash has bonded with nitrogen atom, our R dash will be here, and then one hydrogen, two hydrogen atoms. Now since nitrogen has donated these lone pairs, therefore it will have a positive charge here. Now, alkylation means the addition of an alkyl group. Therefore, now this nitrogen need more electrons as it is positive. Now, therefore, now we know that the halogen atom we know that there is an halogen atom in the solution. Therefore, this halogen atom takes this hydrogen, bonds with this hydrogen, and then the two bonding electrons cause and fulfills the deficiency of the electrons in nitrogen atom, and we will be getting our resultant product. Now, this is our product. Now, if another molecule of alkyl halides, this is the secondary, if another molecule of alkyl halides react within the solution, then the lone pair nitrogen atoms attack the same gas as it that occurred in the first step, and then this along with the bonding electron will leave. Therefore, we will be getting R, and our first R is here, and then the second R, and then we have one H, the H here. Now, positive charge, a positive charge will be here. Now, another halogen atom is here. This will take the hydrogen atom, and then the bonding electron pair will go ahead and fulfill nitrogen's deficiency. Therefore, our product here will be. Thus, in this way, amines undergo alkylation reactions. Now, the second one is our acylation. Acylation reaction. Both aliphatic and aromatic primary and secondary amines react with acid chlorides, anhydrides, and esters by nucleophilic reaction. Now, this reaction is known as the acylation reaction. Now, in acylation reaction, our amines will react with ester, acid chlorides, and anhydrides to give our resulting product. And when this acylation reaction, our final product will be amide. It will give us amide. Therefore, now let us check our primary. Let us check now. This is a primary amine. Now, when primary reacts with an acid chloride, acid chlorides, lone pairs goes and attaches. Notice as soon as the lone pair on nitrogen atom comes and attacks the carbon atom, since carbon cannot form 5 bonds, it will automatically cope to electron atoms, the oxygen atom, and then now when this happens, the oxygen atom again back bonding occurs, and as the back bonding occurs, one bond, there's breakage of one bond, therefore one bond breaks, and this bond breaks and Cl, the chlorine atom leaves. Therefore we will have here CH3. Now we have this as it is C, and then the nitrogen has bonded with the carbon atom, therefore our nitrogen would be here, the two hydrogens here, and then our C2H5. Now our nitrogen will be diffusion of electrons, therefore it has a positive charge. Now we know that we have our Cl minus here. Now this Cl minus comes and takes this hydrogen atom, and the bonding electron pair moves to the nitrogen atom. Therefore our product here will be CH3, C double bond 0, and H. The lone pairs will back to the nitrogen atom, and C2H5. Now this is our resulting product amide. Now this is known as N-ethyl. Since the ethyl group is attached to nitrogen atom, we will first preference N-ethyl, ethane, E-T-H-A-N, amide, therefore AMI, ethanoamide, N-ethyl, ethanoamide. That will be our product. Now let us check another one more example. Now C2H5NH. This is our secondary amine. The secondary amine reacts with. Now let us check if this reacts with anhydride. Our product here will be, now the lone pair nitrogen atom attacks the carbon atom. Either this carbon atom or this carbon, it would be the same. Now as soon as the lone pair attacks the carbon atom, since carbon cannot form 5 bonds, therefore this bond, the pi bond would break and cause the oxygen atom, and at that moment back bonding occurs, and then one bond needs to break, therefore this bond breaks and this group leaves away. Now therefore our product here will be CH3, C double bond 0 from here. Since this is already left, now we will be having here our CH3, C double bond O. The nitrogen atom has come here, nitrogen, and then our hydrogen atom is here, and then C2H5 whole 2. The nitrogen atom here will have a positive charge. Now we know that there was CH3, COO minus, CH3, COO minus was removed, therefore this is the removed. Now this CH3, COO minus takes away this acidic hydrogen, and then the bonding electron pair goes back to nitrogen atom to fulfill the deficiency of the lone pair electrons on nitrogen atom, and our product here will be CH3, C double bond 0, and C2H5 whole 2. Now thus this will be our product. Now N di-ethyl, two ethyl groups, therefore the N and the two ethyl groups are attached to the ethyl group, N di-ethyl, ethanoamide. So this will be our resulting product. Now for tertiary amines, in tertiary amines there is no acidic hydrogen. Our tertiary amine is here, R and R and R. In this our tertiary amines there is no acidic hydrogen, so therefore the reaction cannot, although the reaction here may be proceeded, the reaction from here, the reaction won't occur because there is no acidic hydrogen in tertiary amines. Therefore the reaction would stop, and acylation reactions are shown only by aliphatic and aromatic primary and secondary amines. Now let's move on to our third chemical reaction of amines, that is our carbylamine reaction. Now some important points to be noted in the carbylamine reaction is the first one. This is also, the carbylamine reaction is also called isocyanide isocyanate because there's formation of R and C, or aryl alkyl isocyanate or aryl iso. Let me write here like this: aryl or alkyl isocyanate. The end product is this. Therefore, this is also known as isocyanate. Now, the second most important point is the carboamine reaction is only given by primary amines. This is one of the most important point here. The carboamine reaction is only given by primary amines. That is, it will be either alkyl or aryl, but it would be only our primary amines. Now that, and the third is, now our primary amine reacts with, now in this reaction, carboamine reaction, CHCl3 chloroform plus in a basic medium potassium hydroxide, and when it is heated, now we get our resulting product, that is isocyanate. That is our product KCl plus H2O. Now this is why the reaction is also known as isocyanate, because there is formation of an isocyanate here. Now, how will we know that this reaction is also used for differentiating primary amines with that of secondary and tertiary amines? Because when we do this reaction, when this reaction occurs, if in the solution there is primary amine is present, then the isocyanate has a foul smell. Say like a nauseating smell, a foul smell. So the foul smell indicates that our restarting amine is a primary amine, and thus this reaction is also used for differentiating primary amines from secondary and tertiary amines. Now, if we want to balance the equation, if 3, therefore here we'll have 3KCl and 3H2O, primary amines. Now, for example, in exams, the question may be here: RNH2, CHCl3, KOH or NaOH is the same in heat. What would be our product? Then the product here was CH3 and C, that is our isocyanate. Now let's see the mechanism. Now here, this is our chloroform molecule. In the basic medium we have KOH. The role of KOH is to supply OH minus ion. Now, therefore, this OH minus takes up this hydrogen, removing water, and then the bonding electron pair goes and adds up the hydrogen. Therefore, we'll Cl, C, Cl, and then Cl. Now, there will be formation of a carbene. There will be formation of a carbene here. Now, we know from here, in this reaction, we know that OH minus has already been supplied here. Now, K plus is in the solution. Now, the K plus takes away the Cl from here. The K plus along with this Cl minus along with its bonding pair leaves along with the KCl in the solution to form our product here, Cl2C, and then the lone pair would be here. Now this has an incomplete octet. 1, 2, 3, 4, 5, 6, 7, 8. The octet here is incomplete. The octet is incomplete. Therefore, it acts as an electrophile. Now, therefore, this dicarbene, there are 2 chlorine atoms. Therefore, this is dichlorocarbene. Now, even though there is lone pair, one question may arise here. Since there is already lone pair, this should act as a nucleophile. But this is the molecule in chlorine. 1, 2, 3, 4, 5, 6. There are only 6 electrons, but it should have 8 electrons in total to complete its octet. But since in this molecule the octet is incomplete, therefore this dichlorocarbon acts as an electrophile. Now this is the main ingredient in the dichlorocarbon is the main ingredient in carboamine reaction. Now the main reaction comes here. Our primary amine we have here this is our electrophile. Now since ammonia, the amines are good base, it can supply electrons to act as nucleophile. Now therefore the nitrogen atom gives away its lone pairs to the chlorine atom to the electrophile, and then our nitrogen would have positive charge, and then our dichlorocarbon would come in. Now a negative charge would come here because the lone pairs was given to the carbon atom. Now KOH, we know that KOH supplies OH minus. Now this OH minus takes up this nitrogen atom, and then this bond cause the bond to be, along with the two bonding electron bond cause and adds up here. As soon as this bond cause and adds up here, the chlorine atom along with the two bonding electron leaves. Therefore there will be removed. We know since OH minus has already been supplied, K plus ion will be in the solution. Therefore there's removal of H2O from here, and then KCl will also be removed. Therefore our product here, now we will be getting our product R, and 1H is here. Our nitrogen is still positive here. A double bond would be formed here, and C, the minus sign would still be in carbon atom, and since one chlorine atom has left, another chlorine atom is here. Now another KOH acts up here. KOH supplies OH minus, and then this takes up the H plus H of the proton, and then the two electrons, there will be removal of water. The two bonding electron comes and adds up here, and as soon as this adds up here, the chlorine atom along with the two bonding electron leaves. Therefore there will be removal of gas Cl. Now therefore our product here will be R and plus triple bond, since one more bond has been added up, and then our carbon with negative charge. So this is our resulting product, isocyanide. Therefore in this video we have come to learn three chemical reactions of amines, that is alkylation of amines, acylation of amines, and carboamine reaction. One important thing in carboamine reaction is this reaction is only given by primary amines. It can be either alkyl or the aryl amines, but this reaction would only be given by the primary amine. In the next videos I'll be discussing the remaining chemical reactions of amines.